our last video in the series of naming these formulas, naming and writing formulas for compounds, is probably the hardest one, and it has to do with acids. So that's what we're going to do today. If I can find my slide. Here we go. So first thing you've got to know is that there's actually two different kinds of acids. We have the first type, binary acids, and then on the next slide I'll show you what oxyacids are. So binary acids, think of the prefix bi, that actually means two. So it's compounds composed of hydrogen and one other element, okay? So if you look at all these examples down here, I have hydrogen and only one other element, so that makes it a binary acid. And when I see that, I have to know to remember to put hydro in front. So it's hydro, whatever element it is, ic acid. Okay, so for example, HCl is binary. It's made up of hydrogen and chlorine, and we call it hydrochloric acid. HF means it's hydrofluoric acid, HI is hydroiodic acid, and HBr is hydrobromic acid. Okay. Another common one is H2S. Okay. This would be hydrosulfuric acid because it's, again, made up of hydrogen and sulfur. So that's pretty easy and pretty straightforward. But again, you just have to remember, if I see the word hydro in front, or if I only see two elements in the acid, okay, then it's a binary acid, and these are the rules that I follow. Now let's get a little bit more complicated. So here's an oxyacid. This is an acid formed by combining hydrogen with a polyatomic ion that has oxygen in it, okay? So all of your 8 ions that I showed you in the last video, those would all work. So when they combine with hydrogen, they make what is called an oxyacid. So an example is 2 hydrogen ions can combine with a sulfate ion and make sulfuric acid. Notice there's no hydro in front here. Okay? The word hydro, or that prefix hydro, is only for binary acids. These are not binary because I have actually 3 elements when I look at the entire compound. All right, so what's the rule? The rule is basically, again, I always start with the 8s because I find them the easiest to remember. If my acid contains an 8 ion, such as sulfate, I change the ending to ic acid. If the ending is ite, so if my polyatomic in the acid ends in ite, then I change the ending to us acid. Okay, and I have no real way of remembering that other than I remember that the ite in ite does not match up with the ike in ic. Does that make sense? So if I have a sulfite, I'll never turn that into a sulfuric acid. So the I goes with the us acid, and the 8 goes with the ic acid. So not the best way to remember things, but that's how I do it. And then the hypo and the per, again, just stay there. You don't even touch them, and you don't change anything about them. So again, here's my ite, and it changed to us acid. I did have hypo in front, and that stayed. So I had hyposulfite, changes into hyposulfurous acid. And then again here, the per sulfate changes into per sulfuric acid. All right, so now you got a lot more rules to remember. Can you name or give the formulas for the following compounds? I believe you have, again, a bunch of blanks in your notes. Try those out. Even try 1 or 2, pause the video, and I'm going to show the answers in just a sec so you can check to see if you got them right. So here they are. So let's look at this really quickly. So HNO3. So NO3 1 minus is a nitrate ion. So again, my rule is I change the ending of 8 to ic acid, nitric acid. Hydrofluoric acid. Again, I see that hydro in front, so I know it's a binary acid, so it's hydrogen and fluorine. Check your charges and crisscross, and you're done. HCl, again, a binary acid, so I put hydro in front. Phosphorus acid, so the us acid comes from the ite ion. That means I had hydrogen and phosphite. That's how I figured out that it was PO3 there. Okay, so PO3 3 minus is my phosphite ion. When I combine that with my hydrogen, I crisscross and I end up with H3PO3. Okay, so have a look at those, and if you have any questions about the last four there, for sure bring them up in class. And we'll, yeah, talk more about it then and do lots more practice questions. I actually have one more thing to show you. I find it really easy, but students make a ton of mistakes with these. So please make sure you know them and you don't just think they're super easy and you don't practice them at all. Make sure you practice them. And they're called a hydrated salt. And a salt is basically an ionic compound that contains molecules of water within the crystal structure. And all the water molecules do is help to stabilize this ionic salt, okay? So for example, copper 2 sulfate, okay? So CuSO4 is actually copper 2 sulfate, okay, which I've named here. So just kind of ignore the pentahydrate for now. So copper 2 sulfate is CuSO4. And if I go into my back chemical storage room and I pull that out, it's actually more stable when it has some water molecules on it. So how many water molecules does it have? Well, for every one molecule or for every one copper 2 sulfate sort of formula unit, we have 5 water molecules that help to balance it out. So what I've got here is a hydrated salt. So how do I name it? I name the ionic compound just like I did the copper 2 sulfate. And then the second you see the dot here, you know it's a hydrate, so you follow the rest of these rules. You use the prefix for 5 and then the word hydrate. So that's how I got this full name, copper 2 sulfate pentahydrate, okay? So the copper 2 sulfate, that's my ionic compound. The penta is the prefix for 5, and then hydrate symbolizes that it's water that's helping to stabilize this ionic compound, okay? And the last thing is an acid salt. So you don't need that writing there. So an acid salt is a salt that is formed when only some of the hydrogen atoms in an acid are replaced by a metal. Okay, so if that's the case, you basically name it the same way. Some of these polyatomic ions end up being a lot more common, but here's an example of an acid salt. So carbonic acid, what I can do is actually take away, so if I take away one hydrogen, and I replace it with sodium. Okay, I still have a positive sodium and a positive hydrogen. Those two positive charges counteract the 2 negative charge on my carbonate ion. And so my formula is still neutral, so it is still stable. But the way we name that is basically just as it's written. So we name the sodium, we name the hydrogen, and then the CO3 2- ion is a carbonate ion. So it's sodium, hydrogen, carbonate. One of the polyatomic ions that I ask you to memorize is an HCO3 1- ion. Okay, this is also called bicarbonate. Okay, that's one of the polyatomic ions on your green sheet. So if I take a sodium ion and I crisscross it with this bicarbonate ion, I actually get the exact same formula. Okay, so another name for this compound is also sodium bicarbonate, and I would accept both answers on a test. Alright, so this video basically just showed you 4 different types of compounds that aren't super common, but you do need to know, okay? So we went through binary acids and oxyacids, and then we went through hydrated salts and acid salts. So make sure you know those, and we'll do lots more practice questions as per usual in class.